All right, so here's what I want you to see. One half, 1/4, 1/8, 1/16, 1/2 to the n. What is, now we're talking about the sequence. I am not talking about the series, I am talking about the sequence. What is the limit as n approaches infinity of a of n? It's 0. Okay? The further I go this way, the numbers get smaller and smaller until I approach 0. Good? Okay, let's look at what we did with 3/10 a minute ago. We had 3/10, 3 100ths, 3 1,000ths. What is the limit as n approaches infinity of 3/10 to the n? Which again,
well, for sequence, yeah.
it's 0 for sequence, right?
Yeah.
Okay, are you still with me? All we did was talk about the sequence. We said that the limit of the terms goes to 0. Good. Now let's talk about the series. Okay? We're not talking about sequence. I'm talking about adding it all up now. What did we say sigma I equals 1 to infinity of 1/2 to the n equals? 1. It converges. So you look at this and say, oh look, that went to 0 and that converged. Oh, interesting. How about this? I equals 1 to infinity of 3/10 to the n. That equals? Equals 1/3. Oh, converges. So now here is the question. The question is if the sequence goes to 0, if the limit of the sequence goes to 0, does that guarantee that the series will converge? Well, to help us think about that, I'm going to give us a different series. I'm going to give us what's called the harmonic series, and we saw this last year. Anyone remember what the harmonic series is? It's 1, 1/2, 1/3, 1/4, 1/5. Right? So, what is the limit as n approaches infinity of a of n? It's 0. What's 1/infinity? 0. So here's the question. Will this series, or will this sequence, if I add them up and turn it into a series, will it converge or diverge? So far what we've done, everything is converged. Anyone want to place bets?
I remember it.
It diverges. And the reason it diverges, I can show you a simple proof. Here's 1 plus 1/2. So far, so good, yeah? Okay, now I'm going to group 1/3 plus 1/4 together. Which of these terms is the smaller term? Which is smaller, a third or a fourth? A fourth is smaller, right? So if this were a fourth plus a fourth, what would I have? I'd have a half. So I know right here, this term is bigger than a half, for sure. That term is bigger than a half, for sure, right? Okay, so now I'm going to group the next ones together, 1/5, 1/6, 1/7, and 1/8. Okay, what's the smallest in that group? An eighth. So if I made these all eighths, what would I get? Oh, I'd get a half again. Okay, so I'm going to group now, instead of, see, notice I grouped 2, then I grouped 4. How many am I going to group this time? Okay. Now I'm going to group 1/9, 1/10, 1/11, 1/12, 1/13, 1/14. I hope you get the pattern because I don't want to have to do this again. The next one's going to be hassle.
Yeah.
So I grouped 2 of them, then I grouped 4 of them. This time I grouped 8 of them, right? So my groupings are going up by a power of 2, right? Okay, here's 16. How many elements do I have?
8.
I have 8 elements. So if I made these all 16, so what I have? Half. So as long as I keep grouping these in powers of 2, I keep getting numbers that are bigger than a half. How many terms do I have? So do I ever run out of terms? No. In fact, I could be grouping these by the quadrillions, and it doesn't matter. I don't run out of terms because there's an infinite number of terms. So I have an infinite number of what? Halves. If I have an infinite number of halves, this clearly diverges. This is the point that people miss. Okay? If my series is going to converge, if it has any hope of converging, if it has a prayer of converging, the sequence must go to 0. Because if it doesn't, if this goes to some number like 1, I'm adding up 1 an infinite number of times. That's going to diverge. If the series is going to have a chance at convergence, the limit of the terms of the sequence must go to 0. Is it a guarantee? No. If I have, because over here, the terms do go to 0. That is not a guarantee of convergence. Okay? This works one direction. The direction it works is if I put it in the negative, if the limit of the sequence of terms does not go to 0, then you know for sure the series diverges. But just because the limit of the sequence goes to 0 does not guarantee convergence. It is a necessary but insufficient condition.
They have both of those in the book.
What's that?
They have both of those in the book.
Well, yeah, they're fabulous. They should take their cues from me more often. So do you know what a necessary but insufficient condition is? Here is a necessary but insufficient condition. Right here, I have the winning lottery ticket. I know it looks like Morgan Grubb's homework, but it's actually the winning lottery ticket right here, okay? Woohoo! I won the lottery. And we'll assume that the lottery is $100 million now, right? Okay? Is possessing the winning lottery ticket a necessary condition for becoming the millionaire? Yeah. If you want to become the millionaire with the lottery ticket, you got to have the ticket, right? Is it a guarantee? No, I have to go in and redeem it. If I just keep this ticket in my pocket and wait and wait and wait, I'll never get my money. Having the ticket is not a guarantee that I'm going to be a millionaire. What do I have to do? I also have to go in and redeem the ticket, right? That's like this. This is a necessary condition for convergence, but by itself it's not enough. Think of a car, okay? I have a car. It has 4 tires and a steering wheel and some doors and stuff. Is it a guarantee that because I have 4 tires and a steering wheel and doors that my car runs? No. Having a steering wheel and tires are necessary for the car running. It's a necessary condition, but it doesn't guarantee the car will run. Maybe the engine's broken. Maybe I don't have any gasoline in the car. Maybe the electrical system is fried. So it's important when we're talking about series and sequences to keep it straight. What is a necessary condition but not a sufficient condition? Yes? Okay. So we've seen convergence and we've seen divergence. You can cut.